This is a brief overview of the nature of light, Module 7, which is the second last module of the HSC physics course. And it basically explores the concept of light. Now, for centuries, thinkers have pondered the very nature of light. The very title of this module is the nature of light itself. So is light made of particles? Is it a particle? Is it made of waves? Is it a wave? How can the results of passing light through one slit, or even two slits for that matter, be interpreted in terms of the structure of light? Why does light separate into a rainbow when you pass it through a glass prism? What's the light from stars tell us about the universe? What happens as you move close to the speed of light, which is around 300,000 k's per second? Why do different elements give off different colors of light, like hydrogen, helium, lithium, so on and so forth? And so in this module, we'll be exploring these very questions, looking at what light is, what it does. And this module is broken up into four main sections. First section is the electromagnetic spectrum. The second is the wave model of light. Third part is the quantum model of light. And the fourth part is light and special relativity. So the first part looks at early attempts at describing light. So the first successful attempt was that by a Scottish theoretical physicist named James Clerk Maxwell in the 1860s. So he theoretically showed that light is an electromagnetic wave by unifying electricity and magnetism. And his theory was later verified by a man named Heinrich Hertz, a German physicist, who experimentally verified Maxwell's theory, and he discovered radio waves in the 1880s. We then go on to look at the historical key experiments involving the measurement of the speed of light from the 1600s all the way through to the 1900s. And we'll see that due to advancements in technology, this is what's made that's what's made the current measurement for the speed of light possible. After that, we'll look at spectroscopy and stellar spectra, looking at how we can determine a star's mass, its surface temperature, its rotational velocity, its linear velocity, its chemical composition, just by looking at its spectrum. We'll then go on to look at the wave model of light in terms of Huygens' idea. So Christian Huygens was a Dutch scientist who lived in the 1600s, and he came up with the wave model. We'll also look at another model, the particle model of light, also known as the corpuscular model of light, proposed by Newton in the 1700s, the early 1700s. And we'll look at other properties of light, things like diffraction and interference, polarization of light as well, looking at Malice's law. We'll then move on to the quantum model of light, so looking at the work of Max Planck, the German physicist, who kick-started the quantum revolution in 1900. And we'll also look at things like the photoelectric effect. So Einstein's model of light. Einstein believed in light being made up of particles. And this will then lead us into Einstein's theory of special relativity, which he proposed in 1905. And we'll look at the consequences of what happens as you move close to the speed of light. So we'll look at things like length contraction, time dilation, relativistic momentum, and of course E equals mc squared. We'll also look at evidence for Einstein's postulates, Einstein's ideas, such as the Michelson-Morley experiment. So it's a pretty broad topic. So we'll begin with the very we'll begin at the very basic description of light in terms of Maxwell's theory of electromagnetism in the 1860s all the way through to the 1900s, looking at how light behaves in terms of how we perceive everyday reality. So everyday reality is not how we perceive it, according to Einstein. As you move close to the speed of light, lengths become warped, time becomes warped as well.